So now, before going back to the previous slide once again, let me tell you what is a plate. That is very important to know. And as you see this sad guy, he is thinking those difficult concepts again. Yeah, indeed, this plate concept, this cross-section figure is very difficult sometimes to remember, to recapitulate in the exam pressure time. Because there are so many variations, density variations, level variations, this crust, that crust, oceanic plate boundaries, etc. So this guy is genuinely sad, but we will try to make it very simple. Let's see if we can do that. See, this is the picture of our earth. As you see, there is this red colored triangle. So we have taken this cross section up over here. You can make every similarity in this picture and this picture. Your job is to remember this particular cross-sectional figure as clearly as you can. Maybe you can draw it 3 to 4 times, maybe 10 times, but simply remember this, mug it up. You might tell me that, oh, this is very simple. I know there is core, there is mantle, and there is crust. Everybody knows this. What is there? No, this is the basic structure that I have given to you. The basic structure of the Earth's cross section. In future, I will tell you probably the different densities, the densities of the inner core, the densities of the outer core. Probably I will tell you the density of the lower mantle, upper mantle. Probably I will tell you the density of asthenosphere. Maybe I will tell you the names of these discontinuities. Okay, maybe I will tell you that why this mountain is formed over here. So there will be lots of complexities that will creep into this particular picture. So, but this is the basics. If you can get hold of this, there will be no issues. So please, I request all of you to draw this 3-4 times simply with all these diagrams and whatever is written over here. Just mug it up. Now let us go to the concept part. And after you practice the diagram, you have to remember only few things regarding this. And after that, we will move forward. What are those few things? Number one, you have to understand the concept of plate. What is the plate? I am telling you something. And this is what you are going to write down in your exam paper. Plate is the rigid lithospheric slabs or rigid and solid crustal layers, and which are technically called plates. Okay? The whole mechanism of the evolution, nature and motion of the plates and the resultant reaction is known as plate tectonic. In other words, the whole process of plate motion is referred to as plate tectonics. So what we understand that these plates move, and when these plates move, that is known as plate tectonics. Now, these plates are moving over the weak asthenosphere. You see asthenosphere over here, this cross. So this is weak asthenosphere. And individual lithospheric plates glide or slip slowly over the surface of the globe, much as a pack of ice of the Arctic Ocean drifts under the dragging force of currents and winds. So simply, plates are nothing but lithospheric slabs or the crustal slabs, as you can see here in this diagram. See, lithospheric slabs or crustal slabs which glide over the weak asthenosphere. Asthenosphere is a layer. Now I want to go a little detail. As you see that this asthenosphere is marked by the green dotted line. It is a part of upper mantle. Okay, remember this. This is a part of upper mantle. Upper mantle is till this plane. Okay, this is upper mantle from here till here. But asthenosphere is a part of upper mantle. Right? Get this thing correct. Asthenosphere is the upper part of the upper mantle. Okay, and the crustal plates that you can see here, like this is the crustal plate, this is another crustal plate, These glide over this asthenosphere. Get this much concept in place. That's it for you. Okay? Now, there is another very beautiful concept. There are many plates, as you can see, they are floating over the asthenosphere, the weak plastic asthenosphere. Plastic means not liquid, not solid, semi-molten. That is why they are called weak, right? Now these plates are moving over that. Now the second concept that you should remember. Some of the plates will subduct below some other plate. Okay? Clearly you can see from here. This plate is floating above and this plate is subducting below. Also in this original art picture you can see I have made this plate is above, this is subducting below. This plate is subducting below, this is floating above. This plate is floating above, this is subducting below. So there are many plates. Some of the plates are subducting below the other plates and some of the plates are floating above. Simple concept. I have said nothing new. You might ask why is it so? The simplest answer will be the lighter plates will float above, the denser plate will subduct. Up till this, I think you've got it clear. Now, hoping that the concept of plate is clear with you, I'll be comfortably use the term plate from now onwards. Now, coming back to this particular slide where I will be explaining to you the evolution of the primitive crust. So, let's say you are trying to write an answer on this. So, how will you write? I will just simply tell you that Earth was formed from one hot gaseous nebula. Nebula is a rarefied system of gases which can consist of many enormous galaxies. From one such nebula, our solar system and the Earth was formed. When Earth was born, it was like a hot gaseous nebula itself. Through a process called degassing, the nebula let out several atmospheric gases like carbon dioxide, like nitrogen, like the water vapor, etc. And by degassing, the primitive atmosphere was formed. In the primitive atmosphere, these particular gases like carbon dioxide, nitrogen, water vapor, etc. differentiated according to their molecular weight. Like the water vapor, which always stays closer to the Earth's surface, that created the first clouds by condensation process. And while the hot gaseous nebula-like Earth was cooling down, this creation of cloud and the consequent precipitation helped Earth cool faster. And in the process of cooling, the nebula-like Earth, which was very rich in several minerals, gave rise to one internal zoned structure of Earth. Slowly, it means that slowly the trizonal structure of Earth, like the core, the mantle, and the uppermost crust, got developed. And as soon as the crust or the primitive crust developed, scientists believe that those primitive crusts were very thin and were divided into plates. But the idea of plate in plate tectonic is completely different from the primitive plates that developed millions and billions of years ago through the cooling of the Earth. But when this primitive crust was formed, the hot nebula towards the core of the Earth was giving rise to magmatic current. Magma means lava. This magmatic current coming upwards as convection current of liquid magma. Now there is one explanation. You might ask that why there is this convection current? See, when Earth was a nebula, there could not be radiation, because radiation only happened in vacuum medium. Like the photon from the sun comes to our Earth through radiation, because there is absolutely nothing, void. But here Earth was a nebula, and through cooling it has already solidified a little bit. So radiation is taken out. There is no chance of radiation. Now there is conduction, but conduction also cannot happen, because through cooling Earth has developed some stony structure. The minerals here and there were solidifying, and the rocks and the minerals are bad conductor of heat. That is why only magmatic convection currents were possible. Okay. Now this convection current, the diverging arm of the convection current, keep hitting the primitive thin crustal plates. And while this diverging arm of convective currents kept on hitting the thin crustal plates, it melted out and broke off. Now, while this magmatic flow was coming from the core towards the crust, there was some chemical reaction that was taking place in the magma. Putting things into perspective, I want to tell you that this magmatic current that was coming from the core, or maybe the lower mantle of the earth, were traveling thousands of kilometers to reach to this thin crustal plate. While coming up, the character of the magma kept on changing, and it changed according to something called BOWEN series. I will explain this to you. It's very simple. But then you should remember one thing, that after this BOWEN series chemical reaction took place, this magma changed its character, and the basaltic ocean crust formed. Okay. Now I told you this is oceanic crust, basaltic oceanic crust. After this basaltic oceanic crust was formed, and the magmatic convection current kept on hitting it, it also melted out. And through another chemical reaction, which is a part of BOWEN series itself, the first granitic continental crust formed. So this explains our 11-point flow chart. Now I will go into a little greater detail. So hoping that this 11-point architecture is very clear with you, and also this particular structure of core, mantle and crust is very clear to you, we will move to the third part and the last part of this chapter, which is very interesting. Let's go to that diagram. Look here. I told you that Earth formed as a nebula. This is a part of the Earth. We have taken a cross section. Earth formed from a gaseous and hot nebula, and it kept on cooling slowly. That story I have already shared with you. Now, while the nebula, the gaseous hot nebula, cooled down, it is very natural that some lava or the magma will form, right? Because that nebula had lots of minerals which formed the primitive magma flow, which has been shown here by these dotted lines. I hope you are understanding the story very well. This is the magma which is coming from below, and Earth has just started cooling. The crust has formed. These are the crust. This is just formed primitive crust, and the magma is flowing. Now you remember I told you the diverging arm of magma. As you can see from here, the magma is coming up over here, and when it is getting obstructed by the primitive crust, it has no other way but to diverge. So this is called the divergent arm of the magma, as simple as that. Now I also told you that the primitive crust got divided into plate as soon as it was created. As you see over here, I have made the pictures. Some are diverging and some are floating above, some are subducting. Some are subducting, some are floating above, some are subducting, some are floating above. I told you the story. See, you see this diagram over here. And the hot plume of molten magma, these are also called hot plumes, P-L-U-M-E, plumes of molten magma or the lava. This hot plumes of molten magma is continuously rising from the core diagram, you see, through the layers of mantle. Here also you see this is lower mantle, this is upper mantle, all through this magma is flowing above. The upper mantle is made up of peridotite rock. Now I am giving you a new thing. See, before coming to this new thing, I give you one mantra. You remember this. Dog, pee bag. Always remember this. This is your BOWEN series. Dog, pee bag. नीचे से dog, pee bag. Okay? Now follow what I am telling you. It is saying that the upper part of the mantle consists of peridotite rock. So this dog pee bag, this P I am talking about. This P is nothing but peridotite. See, when the nebula was cooling down and the minerals were like solidifying to make the rocks, several types of rocks formed. Try to understand in larger perspective. Molten magma, it is rich in several minerals, so different kind of rocks will form. So near this upper mantle, you have to remember this, never forget that near this upper mantle the rock is peridotite. Dog pee bag ka ye wala P, peridotite. This peridotite is made up of two minerals, olivine and pyroxene. And this olivine and pyroxene are made up of silicon, magnesium and iron. Okay? The simple idea is that this peridotite consists of silica, magnesium and iron. And whenever this peridotite will melt, the silica portion will go up and magnesium and iron will stay there. It is a rule. Always remember, the silicates or the silica is lighter. So whenever something melts, let's say this G melts, G is gabbro, it's a name of a rock. If this melts, the other minerals will stay here, the silica portion will go up. Suppose this is P, P I told you peridotite, G is gabbro I told you. P is peridotite. I said that P is made up of, peridotite is made up of silicon, magnesium and iron. When this will melt, the silica portion will go up because this is lighter. Magnesium and iron will stay. Okay? Again, let's see this B. I said this is B. Dog, pee bag, this B. This B is nothing but basalt. Again, if you melt this basalt, maybe the basalt is also made up of something, the silica portion will go up because that is lighter. You understood? This is a chain. Whatever you melt in the bottom part, the silica portion will go up. You melt something in the bottom part, the silica portion will go up. Okay? So this is the idea. Now we are almost through to the concept. If you have understood this beautiful story, you are almost through. See, I told you the silica will move up, this gabbro will melt, silica move up, peridotite will melt, silica will move up and form something called basalt. So gabbro will make peridotite, peridotite will make basalt, basalt will ultimately make granite and andesite. See, this is andesite and this is granite. Okay, and if I go below, this D and O are two minerals. This is dunite and this is olivine. Okay, just remember one more thing, the dunite and olivine, as you go near to the core is very hot, right? Maybe still it is a nebula. So this cannot be rock. Rocks cannot sustain there. So dog pibak ka D and O are minerals. This is for your knowledge as you are going for geography optional. So you should be a little thorough. D and O, when you will mention, you mention that these are two minerals, dunite and olivine. But G onwards, that is gabbro onwards, these are all rocks. Gabbro is a rock which is near to the like lower mantle and upper mantle junction, and then there is this peridotite, as you see, near to the upper portion of the upper mantle. This is also a rock, and ultimately these are the basaltic crust. Now let me complete my story. As I said to you, that silica will move up, leaving behind all other heavy minerals and keep on forming new rocks. This process is called magmatic differentiation. If you remember, see here, this somewhere I wrote magmatic differentiation. No, I didn't write over here. Anyways, okay, this process is called magmatic differentiation. This diverging magma current also breaks apart the primitive crust now. The primitive crust that were there, this diverging current will break this now. And the diverging magma, the excess of the diverging magma will attach to the trailing end of this crust. So this is something like, if I draw the picture, suppose this is a crust and this is, say, another crust, and the diverging magma is pushing them apart. See, they are breaking here, and some of the magma which will come here, they will get attached to the trailing edge. Trailing edge means those two edges which are going away from each other. Some of the excess magma will attach to the trailing end. And this attachment to the trailing edge will create ridges too, like here, you see, they will form ridges. Probably you have heard about oceanic ridges, mid-Atlantic ridges. This way the ridges will form. And these ridges now will be basaltic in nature. Okay, so see, they started with peridotite, and when they will form the ridges by getting attached to the thin crust, they are now basaltic ridges. See the beautiful BOWEN series. And this primitive crust will get destroyed in some other places. When these new ridges will form, the primitive crust will be pushed apart and it will probably get destroyed over here. Why getting destroyed? Because this is going down and getting melted. See, here also it is going down and getting melted. Now, remember one thing, that this BOWEN series, that is the magmatic differentiation, occurs all along the mantle. That's why I gave you this dog pibak, starting from dunite and olivine, which are minerals, the G, that is gabbro, the peridotite, up till basalt and andesite, until this granite. The magmatic differentiation keeps on happening. And I also told you, only the silicon comes up. Now one more thing you have to remember, when the silicon keep on increasing, three fundamental changes occur. As you see, silicon is moving up, the amount of silicon is increasing. So three fundamental changes occur. Number one, the rock becomes lighter. When silicon moves up, number one, rocks become lighter. Simple thing, rocks are becoming lighter, that's why they are coming up. Peridotite was below, gabbro was even below, basalt is above, granite is the topmost. So the rocks becoming lighter. Number two, the silica magma is most viscous. Viscous means sticky. So simply thereby I mean to say that when this basalt is here, which is having more silica, when this andesite and granite is here, which are having more silica, if they melt, and create magma, they'll be very viscous and sticky, and they will be unable to flow. They simply cannot flow. So remember. And number 3 is, when silica will increase, the melting point will also increase. Okay. Now let us continue with the story. Now the newly created basaltic crust will also subduct because of convection current. Now we have already created the basaltic crust. See, these are the basaltic crust. We have attached these new basaltic ridges. This will also go and subduct somewhere, right? Whatever is getting formed is getting subducted somewhere, and because of this diverging current. And the melted basaltic magma, now this is basalt because of dog pee bag. When this basalt will melt, this will give rise to very viscous magma, right? I told you, because silicon has increased and it is viscous, and it will form volcanic arcs. See one thing. Now the basaltic crust, the earlier thinner crust, the primitive crust, they got melted, and they have been replaced by this red color basaltic crust because of BOWEN series. And when this basaltic crust will also melt, it will give rise to granitic crust. So this is the story. Now this granitic crust will form like this, and some of them will probably give rise to the first continent. Try to attach to your story the rocks becoming lighter, so they will float above, they will not go down. So when they will slowly be erected like this, one fine morning they will come up from the ocean water, and we will probably see the first continents like this. And one more question you might ask, that these were forming only ridges here, these are the only ridges, and suddenly why did you make these big mountains? The answer is, this was basalt, okay, and basalt had lesser silica, but here this is granite. Once basalt melted, it formed granite, and granite has even more silica, so it has become very sticky. That's why when this basaltic crust melted, they gave rise to this higher mountainous structure. And one fine morning, they only created our first continent. After this, what happened? By weathering and erosion, this mountainous region will be eroded, both sides. A thick layer of sediment will deposit in between and ultimately form the fold mountain. So these red mountains will be eroded, and the sediment will be gathered in between, and slowly they will form large fold mountain. And these fold mountains, which are also known as craton, these are called craton. They are called the ancient nuclei of our continent. Okay, and here our story ends, and I will give you a very beautiful synopsis so that you can